This video provides an example of solving an algebraic word problem involving rate, time, and distance. Let's start by reading the problem. Two cars leave a gas station at the same time. One car is traveling west, the other car is traveling east. The westbound car is traveling at an average speed that is 5 miles per hour faster than the eastbound car. After 2 hours, the cars are 190 miles apart. What is the average speed of each of the cars? So let's start by highlighting some of the key information. Okay, we have the westbound car traveling at an average speed that is 5 miles per hour faster than the eastbound car, so that's key. We know they're traveling for 2 hours. They've traveled for 190 miles, and we know that we're being asked for the average speed of each of the cars. So let's start by drawing a sketch just to get a better picture of what's going on. So we start at a gas station, and we have a car traveling east. We'll call that E car. We have a car traveling west. We'll call that W car. We know that they travel for 2 hours, and that after 2 hours they are 190 miles apart. So now let's set up a table. We have W car and E car, and the formula we're going to use is rate times time equals distance. So now let's see if we can fill out this table. Well, do we know the rate, the speed of the cars? No, we don't know that. That's what's being asked. What is the average speed of each of the cars? So we're going to, those are going to be our variables. So we're going to use W for the speed of the westbound car and the variable E for the speed of the eastbound car. How about the time column? Can we fill that in? Yeah, we know that that's 2 hours. Each car has been traveling for 2 hours. And so now we can apply our formula. Rate times time equals distance. W times 2 equals the distance that the westbound car has traveled. So we just write that as 2W. 2 times E is the distance that the eastbound car has traveled. So we'll write that as 2E. So now we need to set up two equations. We have two unknowns, W and E, so we need two equations to solve that problem. So for the first equation, we're going to use the information that the westbound car is traveling at an average speed that is 5 miles per hour faster than the eastbound car. Okay, so we have the speed of the westbound car, which is W, and we know that that equals the speed of the eastbound car plus 5. So that's our first equation. For the second equation, we're going to use the distance information. We know that the distance that the westbound car traveled, which is 2W, plus the distance that the eastbound car traveled, which is 2E, equals 190 miles, right? The cars start from here. The eastbound car travels this distance, 2E. The westbound car travels this distance, 2W. So we know that both of those two distances together sum up to 190. So let's write that equation. We have 2W plus 2E equals 190. So now we have our two equations and two unknowns. So we can use, in solving simultaneous equations, there are a number of ways that we can solve them. The two primary ways are to use addition, the method of addition, or the method of substitution. So for this problem, I'm going to use the method of substitution, simply because I think that would be easier. This is a fairly simple equation here, this first one. W equals E plus 5. So we can just substitute E plus 5 in for W in the second equation and then solve for E. take that value for e and substitute it back into this equation here and get our w. So let's do that. Let's write the second equation. 2w plus 2e equals 190. 2w plus 2e equals 190. And for the w, we want to substitute in e plus 5, right? Because this first equation tells us that w equals e plus 5, so we can just use e plus 5 here, plus 2e equals 190. And now we solve this for e. So we distribute this 2 across this binomial e plus 5, so we have 2 times e plus 2 times 5, which is 10, plus 2e equals 190. Now let's combine our like terms. 2e plus 2e is 4e, plus 10 equals 190. We want to subtract 10 from both sides. We're trying to isolate this e, right? So we need to get rid of the 10 from the left side of the equation. So we subtract 10 from both sides of the equation. So 10 minus 10 is 0, so we're just left with 4e on the left side. We subtract 10 from the right side, we get 190 minus 10, which is 180. So now we need to get rid of this 4, so we divide by 4. If we divide the left side by 4, we have to divide the right side by 4. These 4's cancel. We get e equals 180 divided by 4. Let's go ahead and do that division. We have 4 into 180. 4 goes into 18 4 times. 4 times 4 is 16. 18 minus 16 is 2. Bring down the 0. 4 goes into 25 times. 5 times 4 is 20, with a remainder of 0. So our e equals 45 miles per hour, because we're talking about speed here. All right, so that's the speed of our eastbound car. Remember, that's what we're being asked for in this problem. What is the average speed of each of the cars? So now how are we going to get the speed of our westbound car? Well, we just go back to this first equation. W, which is the speed of the westbound car, equals e plus 5. And we just plug in 45 for e. So let's rewrite this equation. W equals e plus 5. W equals e plus 5. Substitute e equals 45. We have 45 plus 5. And we have W equal to 50 miles per hour. So that should be our answers. And we can check to make sure that those answers are correct by reading the problem. Let's see what the problem was telling us here. It told us that the westbound car is traveling at an average speed that is 5 miles per hour faster than the eastbound car. So is the speed of the westbound car faster, 5 miles per hour faster than the speed of the eastbound car? Well, 50 is 5 miles per hour faster than 45, so that checks out. We also know that the distance of the westbound car was 2w. The distance of the eastbound car was 2e. And we know that when you add those two, you should have 190. So what is 2 times w? Well, that would be 2 times 50. That's 100. 2e is 2 times 45. That's 90. 100 plus 90 is 190, which is what we were told. So the problem checks out. I hope that helps.